Hi, this is Algebra 2, Lesson 13. We're going to talk about substitution and the area of an isosceles triangle. We're starting on page 71. In mathematics, equal quantities can always be substituted for each other. So here's our substitution axiom. If A equals B, A may replace B, or B may replace A in another expression without changing the value of the expression. Also, A may replace B or B may replace A in any statement without changing the truth or falsity of the equation or statement. Also, A may replace B or B may replace A in any equation or inequality without changing the solution set of the equation or inequality. We are going to use this axiom to solve systems of equations beginning with linear equations. So, use substitution to solve the system x equals y plus 5 and 3x plus 2y equals 5. You remember when we're solving systems for equations for linear equations, what we're going to come out with is an x and a y, and those are going to be the point, the ordered pair that forms the point where the graph of this line crosses the graph of this line. If they end up having a false answer, when we go back and check the x and y into these equations, if they turn out to be false, then the lines don't actually meet. Okay? In most of these cases, though, until we actually start talking about that again, most of these should actually plug in. The point should be a point on both lines. So that's going to be our check. Okay, we have x equals y plus 5. That's already ready for substituting. So we can substitute y plus 5 for x in this equation. So we have 3 times y plus 5 plus 2y equals 5. Okay, we're going to use the distributive property and say 3y plus 15 plus 2y equals 5. And now we can solve for y. We have 5y plus 15 equals 5, minus 15, minus 15. 5y equals negative 10 divided by 5 divided by 5. Oops. And y equals negative 2. Okay? Now we can substitute y equals negative 2 into both equations to solve for x, and this is our check. We should get the same number for x in both equations if y equals negative 2. So we have x equals y plus 5, and we have 3x plus 2y equals 5. We're going to substitute y with negative 2. So x equals negative 2 plus 5 means x equals 3. And over here we have 3x plus 2 times negative 2 equals 5. The 3x minus 4 equals 5. Plus 4 plus 4. 3x equals 9 divided by 3, x equals 3. So in this case, our ordered pair is 3 and negative 2. And that's our answer. Okay? Let's try another one. Use substitution to solve this system. 3x minus y equals 11, and 2x plus 3y equals negative 11. Okay, this one, they didn't give us a starting place, or at least an easy one, so we have to make our own. So let's take this first equation because this y has no coefficient, so it'll be pretty easy to solve for y without having to deal with fractions. So 3x minus y equals 11. Let's solve for y. Minus 3x minus 3x. We have negative y equals negative 3x plus 11. And let's get rid of the negative 1. So we have y equals 3x minus 11. Okay? Now we can substitute 3x minus 11 for y in the other equation. So we have 2x plus 3 times 3x minus 11 equals negative 11. Use the distributive property, so 2x plus 9x minus 33 equals negative 11. Put these together, 11x minus 33 equals negative 11. Add 33. 11x equals 22. Divide by 11. And x equals 2. Okay, now we should be able to substitute x equals 2 into both of these equations and get the same value for y. So we have 3x minus y equals 11. We have 2x plus 3y equals negative 11, and we're going to substitute 2 for every x. So 3 times 2 minus y equals 11. 6 minus y equals 11. Plus 6 plus 6. Oops, sorry, minus 6 to get rid of that. Minus y equals 5. That means 5 equals, and y equals negative 5. Okay, let's try solving it for over here. We've got 2 times 2 plus 3y equals negative 11. 4 plus 3y equals negative 11. Minus 4, minus 4. 3y equals negative 15. Divide by 3, and y equals negative 5. So our ordered pair is 2 and negative 5. Use substitution to solve. Our series is x plus y equals 20 and 5x plus 10y equals 150. Let's solve this first equation for either x or y. It doesn't really matter. Let's try for x this time. So x plus y equals 20 minus y minus y. X equals 20 minus y. Okay, now we're going to substitute 20 minus y for x in both these, in the other equation. So we're going to do it into this one. So we've got 5 times 20 minus y plus 10y equals 150. 100 minus 5y equals 10y equals 150, and plus 10y. 100 plus 5y equals 150, minus 100, minus 100, 5y equals 50, divide by 5, and y equals 10. If y equals 10, we should be able to substitute this into both of these equations to get the same value for x. So x plus y equals 20. 5x plus 10y equals 150. X plus 10 equals 20. And subtract 10 from each side. X equals 10. 5x plus 10 times 10 equals 150. So 5x plus 100 equals 150. Minus 100, minus 100. 5x equals 50. Divide by 5. And x equals 10. Yay! So our ordered pair is 10 and 10. Okay? You've done these before. Just take your time and make sure you do the checks. Okay, that's going to become valuable later, so you might as well get in the habit now. Alright, switching gears a little bit, we're going to talk about the area of an isosceles triangle. You remember an isosceles triangle, iso means two and skelos means legs, so this means two legs. Two of the legs of the triangle are equal. When we bisect an angle, we divide the angle into two angles of equal measures. So we have this angle PYX. And we added a z in here, and this z is at exactly halfway between p and x. Okay? So this angle is 1/2 of angle PYX. And this angle is 1/2 of angle PYX. Okay? So this line is bisecting this angle. We can also bisect a line. If we have line TS and we put another place exactly halfway in between and call it R, then we can say point R is bisecting line TS. So R bisects TS. YZ, which is a ray, is bisects angle PYX. And PYZ equals ZYX. To find the area of a triangle, remember we take the base times the height. And for height, we need this height. We don't want 5, we want this height. We call that height the altitude. We find the altitude of an isosceles triangle by drawing a line segment that bisects both the base at a perpendicular angle and the vertex. So the altitude has to split the vertex into 2 so that this angle equals this angle, and it needs to meet the base at a 90-degree angle. So this is a 90-degree angle and this is a 90-degree angle. Since these two angles are the same now and these two angles are the same, that means these two angles are going to be the same. Right? If these angles are the same, because we split the vertex directly in half, so both sides are going to be equal. So these angles are the same. These angles are both 90-degree angles, and so these angles are both going to be the same. So now we can find the area of this triangle because we can find this this altitude using the Pythagorean Theorem. If the length of the base is 4, then the length of this leg is 2, and the length of this leg is 2. This leg is 5, and if we're going from this 90-degree angle, that's the opposite angle. So this is going to be the hypotenuse. Hypotenuse. And then this angle we don't know. But because of the Pythagorean Theorem, we can tell that 2 squared plus x squared is going to equal 5 squared, because this is a right triangle. So 2 squared plus x squared equals 5 squared. We can solve for x squared. X squared equals 5 squared minus 2 squared. We subtract 2 from both sides. This equals 25 minus 4, which equals 19. If x squared equals 19, then x equals the square root of 19. Remember, your answer does not have to be pretty to be right. So, that means the altitude length is the square root of 19. Now that we know that the height or the altitude, it's 21. I don't know why I thought 25 minus 4 is 19, but it's 21. Sorry. Alright, now that we know that the height of the triangle is the square root of 21, we can go back and find the area. The area equals 1/2 base times height, which is going to equal 1/2. The base was 4, and the height is the square root of 21. So this equals 2 times the square root of 21. Half of 4 is 2 times the square root of 21. And if this triangle was measured in centimeters, it would be centimeters squared. So that's the angle of the triangle. Okay? that is it for this lesson. Try your practice problems. Do your homework. Let me know if you have any questions. Thanks.